Everyone, welcome to my STEMIST Hackathon submission. My project is called MatchTech and it's a networking prototype for students. So let's get started. So why did I start working on MatchTech? Well, personally as a high school student, I always noticed that I'm always trying to find hands-on research opportunities, but oftentimes when I'm emailing professors, these often get rejected. And this is the same boat for thousands of students, as only 1% to 5% of cold reach outs actually end up getting acknowledged, and the rest just get ignored or rejected straight out. So what if there was a platform where this rate could increase? This brings us to MatchTech, which is basically a platform where students/lab institutions can input their data if they're trying to land a research position or hire people to join their lab respectively. And the system also provides email address and contact information for both parties to reach out if they are a match. So why MatchTech and not other networking companies? MatchTech has a very specific purpose of only linking interested individuals together. Take LinkedIn, for example. Even if you reach out to someone on LinkedIn, it's a very high chance that you're going to get rejected there too. So MatchTech finds professors and researchers who actually want to work with students and returns their contact information instead, significantly decreasing rejection rates. So here's some of the impact of MatchTech. It basically allows people with different demographics and education levels to do STEM work because of different research level and experience features, and it helps inspire the younger generation to get into STEM. High schools implementing these features can definitely kickstart the next generation's work on research, and as you can see in this graph, disruptive science is dwindling, meaning that there are less groundbreaking discoveries being made, and maybe platforms like MatchTech can help increase these rates. Here are some of the main functions that MatchTech is based off of. TF idea vectorization is a big part, which basically is part of the scikit-learn library for ML. It basically calculates the term frequency or how often a tag appears, such as like chemistry, math, like I already mentioned, and IDF decreases the weights of common tags, increases the rare/more niche ones, basically to add higher impact to rare research categories. And cosine similarity explains how similar two words are by using dot products, and basically zero means that the two vectors, basically the two words are very much indeed not similar and they're orthogonal, so there's no similarity, and one means heavy similarity. So let's take a look at the code. Basically, we just go ahead and import our libraries, but first, before I start off with showing the code, as you can see here, this is the cosine similarity function where I basically just utilize the scikit-learn libraries of cosine similarity to determine the similarity between two different words. And the similarity matrix basically inputs a float between 0 and 1, determining how similar two different parties are to find the best match. And then harvesting distance is basically just how far away two different parties are to make sure that the commute is not too difficult, or if maybe they want to consider online learning. And then calculate location score basically normalizes this score and gives us a score from 0.05 to 1, basically determining how far away two parties are once again. And qualification score basically determines how qualified an individual is, once again, making sure that the institution and the student are very close in similarity. Here's our lab database, which basically includes the labs that are included that we can choose to determine which one is the best match. And then here we have our applicant database, which basically includes the list of all of the applicants who would like to participate in the system. And here is how we can get our applicant input. We have a ton of series of input questions, and if the input is not correct, then it'll print an error statement, and pretty much the same exact concept throughout. And it also returns the new applicant so that it can be stored in our new applicant database in a new ID. And here we have our lab input. So if the organization who is putting it in is a lab, not a student, this is what kind of input they'll be getting, like their university name, their contact email, stuff like that. Once again, our error statements if they've inputted something in wrong. So yeah, let's go ahead and try and see if this code works. So I'm going to register as a student here. If I'm a student, then it's going to ask me for my full name. I'm going to say like Bob Smith. My contact email, I'm going to say bob@gmail. What I'm looking to start my research, I'm going to say like July 2027. My latitude, I'm just going to give a random latitude, 07. It would be like 101.83. Programming experience, I'm going to say like 4. Research topics, Python, data science, And now it's going to print out what kind of research organization is best for me. And it prints out the UC Berkeley Genomics Group, which is 57.2 match, and Stanford Neural AI Lab gives me a 37.5% match. So yeah, here's my student registration. I'm going to do a lab registration. So from the lab name, Stanford, contact email, I'm going to say stanford@edu, availability notes, ASAP, GPS, maybe like 124, and I'm going to say like 2, 4, Python, science, and let's see what it ran. So as you can see here, this participant has a 35.1% match using a cosine similarity algorithm, and it prints a distance, contact email, and all the skills that the student has, as well as their research level. So thank you so much for listening to my submission. Thank you.